I'm Richard. I do a lot of things. Amongst them is Prometheus. If you're also Munich, you might want to talk to me. Of course, we are always looking for people. So also, I'll give the link to the slides later. So you're free to take pictures as much as you want, but you don't have to. So show of hands. Who has heard of Prometheus? That's always improving. It's almost 100%. That's very good. OK, who's actually considering to use it or who's already OK? Who's pocketing it? Who's using it in production? That could be improved. So anyway, what is Prometheus? Prometheus is a monitoring system. It's been inspired by Google's Borgmon. Basically, of course, people left Google. They found they didn't have anything which they liked. So they came up with Prometheus. It's a time series database, so the only thing which you can store is basically metrics, as in a value which changes over time. It's totally based on 64-bit values for efficiency reasons. There is a whole ecosystem of instrumentation and exporters and things around this metric system. It's not for logging, not for events, not for anything which is not metrics. There's one special case, we'll come to this later, and we actually discontinued our own dashboarding solution in favor of Grafana. Of course, it's just pretty and better maintained, so we focus on what we do, and they focus on what they do. So it's really highly dynamic. It has a built-in service discovery. Chief amongst those for most people would be it has native Kubernetes integration. You can just do zone transfer from your DNS servers and just monitor everything which is in one zone. And for migration reasons, you can just have a single file or tons of files where you just pull your services from. There's about a dozen different ones, but these are the main ones. Then what we do not have is a hierarchical data model. So usually if you look at legacy systems, what you very often have is you have like region, site, maybe cage, then you might have customer, then you might have rec. Someone else needs customer, then region. Someone else needs production versus dev. So no matter how you build your hierarchical data model, it will always be wrong the second you finish it, for someone else or for yourself even. So we did away with this whole concept. What we have is label sets. Basically, you have arbitrary text, and you assign values to those text values. So basically, key value pairs, which build a n-dimensional set of data in which you then can just slice and dice your data however you want it. By customer, by production environment, by site, doesn't matter. As long as it's a label, you can do all operations on your data. We have a specific custom-built query language. It's called PromQL. If any one of you is aware of vector mathematics, it's basically a magic thing which handles label sets and does what you intend to do, and then it does vector math on it, which is insanely powerful and insanely efficient to use once you actually get the hang of this. And one thing which we did very early on, we decided we use one single language for everything. So no matter if you're doing an alert, or if you're trying to get data out through Grafana, or if you're doing a dump of the data to whatever your own tool is, you always use PromQL to get access to the data. You always get JSON back with the data, and then we put it into graphs. Grafana puts it into graphs. You put it in a PDF file. You might even export it to Excel for your management. Doesn't matter. You basically have one way in, one way out, so you can reuse what you write, and you can test what you actually do. It's really simple to operate, and it's really brutally highly efficient, and it's become even more efficient lately. So we have this thing which is built with highly dynamic environments in mind. All the cloud-native buzzwords have been ticked. This thing is like the future. Still, it's one monolithic application. And this is something we get a lot of questions about why we do this. We just had someone talk in favor of microservices, and I actually agree, except for one single thing. If you need absolute resilience, then your design goals and your constraints change a whole lot. And that's why we did it this way. Of course, when it comes right down to it, what do you need when you actually have operations? You need cooling, you need power, so your servers are up. You need some way to connect to the server, and you need observability of some kind. The rest you can hopefully fix in some extent of time. But as this is like in this triumvirate of the really, really, really important things, we erred on the side of resilience and ignored everything else. So for 1.x, no, actually it's the next slide, sorry. There's 3 main features for the 2.x series as of right now. You have the new storage backend, which is actually called version 3, because we had 2 storage backends in version 1. You have staleness handling, and you have remote read and write APIs. We will have links to that later, because those talks really go in depth and are quite long. For Prometheus 1.0, what we had was every single time series, no matter how long or short, was one single file on disk. Hand everything else off to the file system. It's better at dealing with all these things anyway, at least if you use proper hashing. And that's pretty easy to implement. It's pretty efficient. It's pretty resilient. Still, we need to change. Why did we need to change? Churn. If time series appear and disappear, they might not ever come back. They might be coming back at a later point. You get a lot of change within your set of time series. And if you have a lot of single files and you are not actually aware of when those start and end, or if they might become relevant at a later point, you need to look at a ton of files, which becomes really, really slow at a certain point. There's one company which will remain nameless. Pretty early on when we went public with Prometheus, they were asking, okay, how much churn can you handle? Because every 15 minutes we have to kill all our containers and we have to spawn new ones. Not like every 15 minutes, but they have 50-minute total length of life. For various reasons, which might not be the best of engineering decisions, but still, fact is, that's their constraint. This is an extreme example, but still, if you're running huge services or just support a huge amount of services or just like run for years, then you really, really have a lot of time series come and go away. So basically, what it looked like in 1.x, you have all these single files and they just go on and on. Now I have a few queries. Maybe I just want to delay the stator of a certain label set. Maybe I want to go back in time a little bit or a little bit more. Maybe I have more or less look back. But now what I actually need to do for all 3 of these examples, I need to open every single file or keep a cache of the state. Which files are relevant for this time slice? So I have to look at a huge amount of data the more and more time series I get. How did we fix it? Quite easily, chunks or blocks. So basically you have 2-hour blocks and all the data which has been created or ingested during this time, or not actually has been ingested during this time, but which is valid for this time, that's the proper way to say it, is stored in one single block. So now if you do a lookup by time, for example, give me the most recent samples, I only open this one block, I mmap it directly from file into RAM, and I'm done. Same for other, yeah, you can figure it out yourselves. So we had a test setup. We had 800 microservice instances and Kubernetes components, kubelets, all these things, which generated a total of 120,000 samples per second. And yes, I mean 120K per second. Of course, this is not that much in Prometheus land, even if you have like years of storage, and I'm being serious. We had 300K active time series at any given time. All the other ones became stale and never returned. Of course, it was basically random label sets which we put in just to have everything. And every 10 minutes, 50% of those pods were killed and restarted. So that's the rough thing we tested, or actually the precise thing we tested. Results. These numbers have been tested, and you're actually invited to reproduce them if you actually want to. We're being serious. We had a 15 times reduction in memory usage. We had 6 times reduction in CPU usage, up to 100%. Times, not percent. 15 times reduction in memory usage, 6 times reduction in CPU. up to 100 times reduction in disk writes, or disk I/O, 5 times reduction in on-disk size, and 4 times reduction in query latencies. And this was, with 1.x, already the quickest metric solution on the market, paid or free. And that's 2.0. There's a downside of handling this extreme churn. Of course, you actually enable your users to use this feature. And obviously, they will start using it. This is good on the one hand. On the other hand, this opens up new issues, mainly the issue of staleness. In Prometheus, basically everything which is less than 5 minutes old, by definition, is considered current, and everything which does not have a data point which is within the last 5 minutes is stale by definition. And it's not returned by default if you look at the current values, blah, blah, blah. So this served as well in 1.x. In 2.x, all of a sudden, those 5 minutes seem like a really long time. Of course, if I churn through my instances this quickly, down alerts continue to fire for something which is already been torn down and is supposed to go away. I might be double counting certain metrics. I might have a wrong average. Of course, I still have stale data in my database returned as being current. And it becomes worse and worse the more churn I have. In former days, we had this issue, but quite frankly, it just didn't really matter, except for in extreme cases. But yeah. So the short version is we had a really, really simple solution. The long version is actually a 1-hour talk, so there's a slight difference. But the short version is basically if a target which emits data goes away, everything which is associated with that target is marked as stale immediately. So it actually goes away. Same for any specific time series from a specific target or any number of time series from any number of targets. Once those are not emitted, every single time Prometheus comes along, this one is immediately considered stale and taken out of many, many considerations. Again, it's a little bit more complicated than explained here. Of course, it really goes into depth. So the next thing we had within 2.x was something to actually get data out of Prometheus. Of course, especially when you have like one single file per time series, it's really, really hard to do proper backups. Of course, you're never in a consistent state. You're always changing bits and pieces. And to deal with this, basically what we did, we have a generic read-write interface, and you just push data by HTTP to some place that can ingest the data, and we can also read it back so you can actually do queries through PromQL. It's obviously not as efficient as if you had it in your own system or in the same system, except for a few approaches which are coming to light slowly. But yeah, it exists, it works, and if you have old implementations, this is actually the preferred way to do upgrades if you still have 1.x instances, and a lot of people do. What you can also do, there's a migration tool which just migrates the storage from version 1/2 to version 3. And there's one feature which we never really went public with, but it's still available. That's what I meant earlier with not when it's ingested, but when that timestamp is, or that value point is actually valid. You're able to tell Prometheus when the specific data point is valid. Like you can put an explicit timestamp. It was not current at the time when you came along, but it was current at X time. In former times, basically you could jump back 20 years if you wanted to, as long as you only appended and didn't try to backfill data. But with the new model, obviously, we have this 2-hour block. So once you write this 2-hour block, all that data is away, and you can't really change. Well, you can change it, but we don't change it for obvious reasons. So if you rely on timestamps, you should probably not do this in the long run. But there's ways around it, so it's actually not a hard problem, but it's still. So this is basically where we stand today. As of right now, 2.2.1 is the current model, and everything I talked about up to this point is what you gained within the last few months. So what's beyond this point? First of all, while I mean, SQL is not like the cloud native or most cloud native approach. Still, ACID databases have their value, their inherent value. So we have pretty much everything which we need except for isolation. We have our atomicity, we have our consistency, we have our durability with the new storage. We are still lacking isolation, and that's being tackled as we speak. What is isolation, or how do we, or is isolation, should I explain it, or is everyone aware of what isolation is? Basically, as long as I'm not certain that my data is good, I'm ignoring it. That's like the short version of what isolation is. So at any given time, we are actually ensured that we are not showing data of partial scrapes, maybe of broken scrapes, maybe of some scrape where the target went away while we ingested the data. Maybe we are not yet finished putting it in all the data structures. All this data which is not, basically either a target should be fully there or the data shouldn't be there at all. Of course, else you will get wrong results. And again, with increased churn, this becomes worse and worse. So how do we solve this? We have a 64-bit monotonic counter. It just goes up and up and up and up. And every single scrape of a target gets one ID. And as long as this ID isn't marked as either fully committed or as fully reverted, in that case it's ignored anyway, it's ignored at query time and we do not return this data. Quite simple in principle, rather complex under the hood. Of course, there's a lot of interdependency within the code, but basically that's it. And if for any reason we kill this process and we restart, we just look at what was the last valid times or the last valid ID. We go from there and we don't actually need to keep any other state. Of course, this would hinder us in a few implementations. So basically we just start counting from 0 again and redo what we had. So the next thing coming within 2.x, again, even before we did all this optimization, we were the quickest ones. And if anyone wants to contend this, we can actually run benchmarks. We did this with a few projects. We won. Still, another thing which we would like to improve is PromQL. Of course, it's already like really quick, so quick that other projects actually adapt our libraries for their own projects and products. Of course, the query language is this quick, yet it could be quicker. For functions which have vectors over time, we see a 5 times reduction in execution time. And the actual garbage we create within Go, which the garbage collector then has to actually grab and toss away, is reduced by 100 times, which I dare say is quite impressive. It's currently being worked on. I would say it will take 1 or 2 more months. We'll probably cut a new minor version just for that feature. So the next thing we really have to do within 2.x is release stability. Looking at everything from, let's say, 1.4, maybe 1.5 to 1.8, it was really rock stable. And people really depended on Prometheus beyond even our guarantees and contracts. Contracts not as in like legally signed, but as our promise to the users, which we keep. And with 2.x, this kind of broke down. We had a few bugs in the storage layer. We had a few bugs in other places. And quite frankly, we had a few issues where people cut beta releases and then people tested them. We were like, okay, this can be released. And someone just snuck in something small. Of course, it's just small. Thank you. That sucked for obvious reasons. 2.2.1, the current one, is the first which is really clean and stable. You don't see any issues. At no time did we really have any data loss bugs within Prometheus, so you could always recover, yet it was still unacceptable to not just have a product which is on spot. Of course, you really have to rely on your monitoring. Your monitoring is what keeps you sane at night. So we have a lot of focus on actually shifting gears and making really sure that we do not introduce anything bad into any release at all. And yeah, what we also do, CNCF is sponsoring a full code review by Cure 53, not driven by these stability issues, Generally speaking, they do it for all the major member projects, and as we're the second largest one, we also get this, obviously. It's mostly focused on security, a little bit of fuzzing, a little bit of pen testing, blah, 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 all these kinds of things, but always when you look at security, you obviously also impact stability. So this is something where we have another venue or another attack vector onto our code base to just make sure it doesn't explode on the user. Special to our security, and this also kind of surprised the guys who are doing the security audit of Prometheus, we deliberately do not make any security, or not a lot, security promises. If you, for example, have your data exposed on HTTP, we just ingest that. If you expose it through HTTPS, we also ingest this, no issue. But we do not, for example, support that we check your client or your service certificate. We do not support that Prometheus keeps a client certificate while connecting to your server. Prometheus itself has no concept of users. It has no concept of authentication, of authorization of anything, for a very simple reason. In a lot of cases, you don't actually need this if you have proper design around this. Still, you obviously want this. Of course, I mean, it's good practice. But it's not good practice for us to implement this. Of course, we are not the experts when it comes to whatever AES extension someone comes up with. That's up for the people who actually write reverse proxies and stuff. So they can keep this, and they actually do this well, and we just more or less ignore it to actually force the user to use proper tools instead of using what we just shoehorned in. And basically, sidecar / microservices. Yeah, I mean, it's the obvious path these days. There's one last large thing, which within Prometheus remains largely unsolved. We are making huge steps, but we're not where we would like to be. It's long-term storage. Basically, if you want to have a redundant setup of Prometheus, by default, you take 2 Prometheus servers, configure them in exactly the same way, and they have no knowledge of each other. And each of those instances does exactly what it does, completely independent of the other instance, which makes all those failure scenarios really, really easy to look at. You basically take a piece of paper and a pen and you're done. Of course, it's really simple to do. On the other hand, what this means, if you have data on one single instance, by default, if this instance goes away, your data is gone. That's not the best of operating procedures. We have several paths to attack this problem. First, again, version 3 storage supports backups. So you're actually able to do proper snapshotting, backups, whatever your deployment model is like. You have the remote read and write API. And there you can just shove all your data into something else. For example, Cortex, which is basically Prometheus built for distributed systems or as a service provider service towards whoever is your customer, and just they toss the metrics at the service and they get them back. You can also run it on premise, but it's more here towards people who provide this as a service and have staff to actually run Cortex. There's also a second layer within Prometheus proper where we implemented this. It's in the storage layer, where you basically have an object store and just toss your storage objects. Because again, we have those 2-hour blocks. It's perfect object storage. Just toss it in there. There's some considerations about index size and indexing speed, but else it works really wonderfully. So now we have 3 fundamentally different approaches, how to solve long-term storage. And within this, we have several different specific solutions within each of those approaches. We deliberately do not endorse any of these. I mean, if they work, you can ask us on mailing list and we'll answer you truthfully, obviously, but we will not be like, okay, this is the one project or this is the one accepted path. Of course, we are not far enough for this, and maybe something new comes up. Maybe we'll never endorse anyone. We don't know. So if anyone claims to be officially endorsed or the default solution or whatever, that's probably a lie. No, it's most definitely a lie. But this is only specific to Prometheus. So looking beyond just Prometheus, the thing we really want to do is to change how all of you do monitoring. And even if you never ever in your life use Prometheus, but we enable the ecosystem of monitoring to change enough for you to just take over a few of those best practices, we are happy. But we are literally trying to change the world, especially with the label set. Of course, I mean, I could list half a dozen or a dozen different monitoring solutions, and all of them have some sort of hierarchical data model in them. And every single one of those is inherently bound by this constriction. It's not good engineering anymore. So what we do, usually or always, within any data exposition, we already expose the labels. So by definition, if whatever you're using is able to ingest this data format, you're already free of this hierarchical model. You are, by definition, able to use label sets. Yet, there's a few people who have issues with supporting something where the brand name Prometheus is all over it. A few projects, and especially companies, have real issues with supporting something else. Quite easy. What did we do? We are spinning out the exposition format of Prometheus into its own project. Last August, we had a face-to-face kickoff at Google London, where we also had a fire alarm, but it was longer than this one. We will join the CNCF as a full member project. I actually have this call with the TOC June 19th, I think. We will have an RFC, so you can sneak an RFC into a tender for whatever you're buying from your vendor. And if they sign this tender, then they are legally obliged to support Prometheus. Yay. Yeah. And currently, basically last week, Tuesday, we finished all detailed discussions, and now I'm actually writing the internet draft, which will hopefully become an RFC. But even this is not going far enough. Of course, while we were pursuing this approach of open metrics, we realized that even this is not going far enough. So what we did with open metrics is we start to support one single event per metric, which might sound somewhat counterintuitive, but it's quite useful. Think of latency buckets. Let's say your service usually takes less than 0.1 seconds, doesn't matter, or 0.1 milliseconds, let's say 0.1 whatevers, but your latency goes up to 10 at some certain points, and you don't really know why. So now if you had a library integration which randomly sampled your calls and then just did a trace by default, and when it's done running, and once it realizes, oh, I took X amount of time, and I need to, and this is in a bad bucket, you actually expose this trace towards whatever is coming along and ingesting this data. So now all of a sudden, if you have issues, you just turn on this random sampling during runtime in your library to support sampling or logging or whatever of anything which is beyond a certain latency level. So especially for histograms, for your percentiles, this is really useful to just attach one data point of information, be it a trace, be it user IDs, doesn't matter. Open Census already supports this. Prometheus already discards it and will continue to do so. Of course, it depends on what you're actually trying to do and what you're trying to solve. And open metrics go beyond this mere metrics. So open tracing, I talked to them, I think, 2 weeks ago. They're really, really into this. They actually want to try and support this from day one once they're finished with their stuff. We will probably hammer this out at the latest in December. Of course, then we'll be able to meet in person. And basically what we want to have long-term is something where you can put metrics, events, logging, traces, dumps, whatever you can think of into one common format, and then bits and pieces of the ecosystem supported. Maybe you have like this huge thing, Influx, Open Census, whatever, which supports everything, which is nice. Of course, it's like out of the box, it works. On the other hand, if you have like 10 different products which are really, really good at what they do specifically, it's a lot easier to take one of these components out in the back and shoot it and just replace it with something else. So monolithic versus smaller services. There's a ton of companies which are already committed to supporting open metrics. It's becoming too many to list. and I couldn't be arsed to have two-side in LaTeX, so whatever. There will also be PromCon, this August in Munich. If you are interested in Prometheus, this is the place to be. CFP is still open for 2 weeks. I just extended it, like literally while sitting here. Sponsorship is still open. Something which is non-obvious, we actually have quite a bit of funding for diversity. So everyone who wants to attend and think they could benefit from this, please do go to PromCon.io and put in an application. Of course, we can, at least for some people, even cover travel and accommodation. So yes, we'd like to change the world. And what we will always have is that whatever your vast amounts of raw data is, getting from this point to reliable alerts, so you actually know if your service is going down or not performing perfectly. This will always be the single most important goal of Prometheus. And this is something we always kept all through inception of Prometheus until today, with every single release. Which is why we'll always focus on simple and efficient operation. We're talking to vendors, hardware vendors as well, especially in the networking space. They also are interested in open metrics. And roughly speaking, what we always try to do is to have whatever a large-scale deployment is, this 10 times. That's what we want to support today. Of course, then you're actually able to grow your service in whatever way. There's more talks. There's even more talks. This talk will be uploaded to here.